This episode of the UnBuild It podcast is brought to you by Huber Engineered Woods. When we talk about Huber Engineered Woods, you know, we say they make Advantech, we say they make zip system, you know, they have liquid flash and subfloor glue and tape. And I think that most of our listeners are fairly familiar with their product lines. They make really high quality stuff that makes our job easier. But I also wanted to let you know that they have a couple of new products on the market that they just announced at IBSX for 2021. They have Advantech X Factor, and they have a new vapor permeable tape. And I think that those things are very important because they go to show what Huber Engineered Woods is really about. They're innovating and they're problem solving before even builders like myself have asked for those things. That process of innovation has kept them at the top of the game, at the top of the pile, and that process of innovation has caused builders like myself who are focused on durability and energy efficiency and really doing things the right way the first time to believe in them as a company and to use their products. We've been using their original Advantech formula since the late 90s as a company, and we've been using this zip system since 2013. So I think that proves to you my belief in the company. I hope that you'll look into Huber Engineered Woods, and thanks for sponsoring the podcast. Let's talk construction management software and what makes a software good. First, I'd say the ability to tackle the tasks that I need it to do, but more importantly, the ability for my team to comprehend the software, my clients to comprehend the software, and everybody involved to actually want to use that software or that interface. BuildBook could be that software for you. BuildBook is simple to learn and use. It allows for constant communication between you, your team members, and your clients. It doesn't waste time with unneeded features, and you won't have to send your team across country to learn how to operate it efficiently. At the end of the day, BuildBook should reduce your stress and your team's stress as well. BuildBook is an all-in-one construction software for today's builders. Whether you're a one-person operation or a large building crew, BuildBook has plans to fit your budget. They don't have any of those nagging sales calls or tricky upsells or hidden fees. You can sign up for a 10-day free trial with BuildBook so that they can teach you and show you what the value is of their product. You should head over to buildbook.co to get started. Don't forget to mention that you heard it from us, the UnBuild It podcast. That's buildbook.co. Thank you, BuildBook, for your sponsorship.
Welcome, everyone, to the UnBuild It podcast. I'm the host for this episode, Pete Yost. I'm here with my good buddy, Steve Basic.
Hello, everyone.
And our special guest, Paul Springer from AeroBarrier.
Hello, hello.
So, Paul, I'm going to do a real quick one-sentence description of AeroBarrier, see what you think. So, AeroBarrier is a technology that uses air pressure through a blower door to take tiny particles of sealant, and the pressure sort of guides them to fill the holes in the building enclosure. How does that work for you?
Yeah, that's pretty good. I mean, to your point, we put positive pressure on a building envelope, causing that air to find all the leaks in a structure. And the technology allows us to atomize a sealant that then follows the air to those leaks and seals them as they go through.
And I just have to take a real quick pause here because what we have is Peter, Paul, and the guy who likes to be jolly or merry. How's that work for you, Steve?
It doesn't.
I figured as much. But the really weak Peter Yost joke, at least we got out of the way. So, Paul, Steve and I are really excited about this episode because AeroBarrier is just such a cool technology. Can you tell us a little bit about how you got involved with AeroBarrier and your background?
Sure. So I've been with AeroBarrier a little over 3 years. I've actually been with the company since AeroBarrier was commercialized. And prior to that, I had marketing and business development roles, mostly in the technology field. So it was a natural fit for me to come to a technology company like AeroBarrier. While I'm not or wasn't as familiar with the construction industry, I was very familiar with this type of company.
And so the AeroBarrier technology is actually the second system that your company has developed, right?
Yeah, that's correct. If you're familiar with AeroSeal, while that's our company name, it's also our other technology that we have a patent on. So in 1994, AeroSeal was patented, and that's our duct sealing technology. So it's the same general principle as AeroBarrier. We pressurize the duct system and close off supply and returns. We protect the mechanical equipment, and we can seal the ductwork from the inside out to less than 5% duct leakage without tearing out any walls or having to do any construction on that property. And it's a really effective way to actually seal your ductwork.
So let me get this straight. Do you have a sealant which is naturally sticky, and you use compressed air to make it into tiny little particles, but they're only sticky when they run and find a hole?
Yeah, so with both technologies, they aren't going to create a mess or a coat over everything, right? The way it's designed is it has to have this change in pressure for those sealant particles to start to collect on each other. So as we pressurize the house or we pressurize the ductwork, it's causing air to be forced out of leaks in that structure, whatever we're sealing. So just because a sealant particle may hit a vertical surface, it doesn't mean it's just going to stick to it. It has to have that acceleration and change of velocity as the air exits the pressurized space for those sealant particles to collide and start to create a seal. So again, especially with AeroBarrier, when you think about a whole house, you can rub the drywall after we're done with an application and you never know we were there. So it's not just going to stick to surfaces because it runs into it. It has to have some things happen along the way for those seals to start to occur.
So after you make them into those tiny particles, they just sort of hang, right? They're small enough that the Brownian movement, the other air molecules can kind of bounce around and hold them in the air space, right?
Yeah, with the pressure that we put on a structure or duct system, we've designed the atomizers that we use, or the sprayers, to create a certain size sealant particle. That particle is about the size of a human hair. And at that size, those sealant particles will actually suspend themselves in air. They'll stay suspended due to the pressure on the space or the ducts. So they'll stay suspended or float in the air. And then the air becomes our method of transport. It just carries the sealant particles wherever it's going. And as it exits the leaks in the structure, those sealant particles collect and seal it.
Steve, I remember back at Building Science Corporation when there was actually a Building America meeting about the AeroSeal technology. Do you remember that back? It's like the early 2000s or something.
Vaguely.
And thinking, that's just crazy. I mean, what a cool technology where, finding the holes is done by physics rather than people.
I call it smart atom technology.
Smart atom. Ooh. High IQ atom. I like it. So, Paul, okay, so I can see that doing it inside a duct, we're in a very sort of controlled environment, pretty much all one type of material, right, that's inside the duct. It sounds as though it took quite a while to sort of move the technology from ducts to considering whole buildings.
Yeah, and to your point, it's a much different application. A duct system is a more enclosed space. It's a little bit easier to control the sealant particles. There's less pressure required to pressurize a duct system. And the sealant is much different, right? If you think about the pressure and temperature variation in a duct system, it's different than what you're going to experience in a building envelope. And also, to your point, they're made of different materials, right? Duct systems, maybe there's a wall cavity or pan joist, or there's different ways that you can put ducts in the home. But those options are a little bit more limited than the variety of materials that can be used in a building enclosure. So the sealant is different. With AeroSeal, it's like an Elmer's glue kind of consistency when it dries. It's water based still. It's safe. It's actually made of the same material that are used in pacifiers and bubble gum. So it's a safe material. It's an inert material. And then with AeroBarrier, it's more like a caulk. It's a waterborne acrylic that when it dries, it looks like a bead of caulk was applied to the joint or to the leak. So again, it's not making a mess over everything, but each one is designed for their specific application.
So you got this technology that will fill holes because the tiny particles under pressure as they move through those spaces accumulate. But I got to think that the bigger the hole, the longer it's going to take to fill that hole. So what sort of prep or sort of baseline level of airtightness does the building have to get to before you guys show up or before you start your technology up?
Yeah, so frankly, we like to say we seal leaks, not holes. So AeroBarrier is not a replacement for poor craftsmanship, right? We still want the framers to do their job. We want the windows installed appropriately. We want all those other trades to do their job as you would expect. And we'll come in and seal the leaks that you don't know where they are or they're hard to get to. But as far as the prep and work prior to, we cover any designed openings. The sealant does not discriminate. If there is a leak in the structure that's less than half an inch, the sealant is going to try to seal it. And what I would say is, as we're prepping windows, supply and return vents, fireplaces, maybe there's a drain that doesn't have water in the trap. We'll take special precaution on weep holes. But as we're doing that prep, if we see leaks and we perceive them to be leaks to the outside of the structure, we will go ahead and hand seal them, right? AeroBarrier is really, really effective at finding and sealing leaks. But if you see a leak and you know it's there, it's much more effective just to use some foam or some caulk. In about 10 seconds, you've sealed it, as opposed to waiting for AeroBarrier to do it. Then AeroBarrier is much more effective in finding the leaks that you don't know are there and doing the work that it's intended to do.
AeroBarrier sealing the holes you can't see or leaks you can't see.
And so I would imagine, since this sealant is atomized and then under pressure, that things like temperature and relative humidity are got to be important to the process.
Yeah, and for anybody that hasn't seen our technology, we have what we call an MCU, the main control unit, that sits outside the house. And attached to that is a laptop. And with that laptop, we can control temperature, we control humidity, we control the amount of sealant being injected into the space at any given time. We control the pressure on the house. And the key to AeroBarriers, every 90 seconds, because we're using a blower door for pressure, we also get a blower door reading. So we can tell builders in real time what the envelope leakage is, and we can dial in that performance based on the spec of the house or what's determined to be appropriate for that structure. So if it's looking for someone to meet code and go to 3 ACH 50, great, we can do that. No wasted time, no wasted labor, no wasted material. We know when we hit it, so we can take the guesswork out of that type of air leakage. On the flip side of that, we can also do the houses like Steve and Jake are doing and take houses to 0.2 ACH 50. It really just depends on the structure. We want to work with the builder, because obviously if you make the building too tight without the proper ventilation, you can cause additional issues. So we don't want to go down that path. So we want to partner with our builder partners and make sure that the structure is designed to meet the requirements meet the air tightness requirements that we're going to put on it.
Steve, you've seen the AeroBarrier process, right?
I have.
Tell me what jumps out to you about that process.
Well, the dialing in is pretty incredible, right? So you can sit there and say, the two houses that we did with Jake, and we did them because we have the ability to go back. So one of the things that we were always worried about is air leakage in general. Is there a degradation pattern? And if we use AeroBarrier, is there a degradation pattern associated with it? So we have these two houses that Jake built, that one is his, one is for a relative of his. So the idea is we would have perpetual access to them. And so we had AeroBarrier come down after Jake built them and got the air barrier intact. And I mean, Jake did a phenomenal job because our stepping off point was right around 0.3 ACH 50. So, I remember
which 0.6 ACH 50.
Yeah, we were half a passive
standard.
house.
Yeah, which is pretty incredible.
Pretty incredible, right? And then we had AeroBarrier come in and take it to below 0.1. I think we were at like 0.06, 0.07, something like that with them. But the ability to just sit there and you just keep running it until you get the number you want was pretty neat. And with Jake's, I think I forget the gentleman's name at Thrive. Paul, help me out.
It's escaping me at the moment too.
Not Bill.
No, it's not Bill. All right. But yeah, the Thrive gent, we'll call him. He said that for Jake's house, we used somewhere a little less than a quarter of the material that they would typically use for an air leakage project. Joe Nichols, yeah. And so.
And what stage of construction did you do the AeroBarrier process with Jake's houses?
We were probably just before the final finish, meaning our air barrier fully intact, obviously windows in, all the drywall was in. There were things like some miscellaneous trim, carpentry, hardwood floors, stuff like that had absolutely no...
But Paul, you can do it as long as you've got your primary air barrier continuous. You can do this process whenever you want, right?
Yeah, and that's another reason we like to work with the builders, because we can apply it rough-in all the way to a fully finished structure, right? And I like to clarify, when we say fully finished, there's a difference between fully finished and occupied. If someone misses an occupancy permit, misses a certification target, we can help in that instance. But we can start anywhere from rough-in on. And really what it boils down to is, when can we pressurize the space? So if you're building with unvented attics, a conditioned attic, we can come in at rough-in because there's no soffit and ridge vent to contend with, and we can pressurize the space at that time. And typically, that's where you've designated your air barrier, right? And take the time just to clarify, AeroBarrier, although the name may lead you to believe otherwise, is not a primary air barrier. We are an enhancement or an accessory to the air barrier. So we would like to identify where the primary air barrier is in the structure and apply against that surface. So with an unvented attic, we can apply at the exterior sheathing. If it's fiberglass insulation, we'll do it exterior sheathing. If it's spray foam, we'll go right after foam. But we want to apply against that surface. Now, if you have a vented attic where the soffit and ridge vent are engaged, like with Jake's house, we would go after first coat of drywall mud, because that's when we pressurize, and typically that is where your air barrier is going to be defined. So we have some flexibility in that, as long as we can pressurize the space, we can apply. But we do like to work with our builders to help understand, the different implications of when you apply and what that means, to ensure we're helping build a high performing structure.
I would think you'd want to ensure that you have the least amount of construction done when you get called in. Meaning that if I'm using, say, zip as my exterior primary air barrier and have Rockwell insulation or whatever in the wall, then I probably don't want the drywall on there if I can help it during the AeroBarrier, because then the AeroBarrier is going to give me or it's going to be falsely working towards sealing some holes in the drywall that I've really not appointed any attributes to, right? So if the drywall isn't my air barrier, there's no sense in wasting AeroBarrier material, time, and money on sealing any holes across the drywall plane.
Yeah, and that's we want to identify the primary air barrier, because that is going to be the best application. And frankly, it also depends on the project itself, right? If it's a single family detached house, the air barrier on the exterior is going to be when we want to apply, or wherever you designate that air barrier. When you start talking about attached products, compartmentalization is a whole different ballgame and beast, that we want to compartmentalize those units from each other. So while we take into account where the air barrier is, that exterior air barrier in multifamily is less of a concern for us, because that's only part of the job that we're working to achieve, right? We want to compartmentalize those units from each other. So we will go at drywall for most multifamily applications. But Steve, you're right. We want to go against the primary air barrier, no matter where that is. And one thing just to note in your example, if there happened to be rock wool in the walls, we would want to go before rock wool was installed, because any type of fibrous insulation like that will just act as a filter, and the sealant particles will never get to the leaks that we're trying to seal.
Steve, what did you have to end up protecting in terms of surfaces in Jake's home?
We didn't, because we were pretty much at, like I said, not quite finished. And honestly, I think at Jake's house, the drywall and blown in insulation wasn't in yet, actually, when we did his house.
And Paul, so let's say we have a typical 2 or 3 bedroom, single story home. How many different spray heads would you put in a building like that?
It really depends on the layout and just the general size of the space. We can put as small as 2 spray heads and as many as 14 into the house. So it really just depends on the structure, the size, but the system is flexible and can accommodate any size house. It's just a matter of us getting on site and taking a look. We don't set up the nozzles to try to address certain leakage points. We set up the nozzles to create a consistent fog within the space, and we let the air do the work. There's no reason for us to try to guess where air is going to leak out. We just get the sealant particles into the air, and we let physics and the movement of the air through the structure do the rest of the work for us. So it's more about creating consistency in the house with the sealant that we're putting in it, and less about identifying where we think the leaks are going to occur.
Building on that, Paul, if you had that house that Peter just ran the metrics on, do you guys go in and do an initial blower door, like a quick assessment? And is your approach different if, say, that assessment was your stepping off point was 1.0 versus 7.0? Is there a different approach?
Yeah, so typically, part of our process is do a pre-test. So it kind of sets the baseline for the structure and kind of gives us an understanding of what that leakage is going to be. Depending on what that leakage is, really determines our next step. Frankly, we've showed up to houses that are 22 ACH 50 when we started, and we don't start at that point.
Those are called barns. Those are barns in New England.
Sorry, Steve, what'd you say?
Those are called barns in New England.
Yeah. So at that point, we will go in and we'll keep the blower door running, and we'll go chase some leaks. There's got to be something big in that structure that's been missed by either our prep or from the trades before us. So we'll go look for that. But once we get around 8 to 10 ACH, we feel pretty good about the ability for us to go do something or do the work, and we'll start it there. But the beauty of the technology is it can handle those types of projects and make efficient use of everyone's time.
We've been talking about new construction, and you've done a lot of research with the Department of Energy and have ongoing research for, in addition to Steve's and Jake's houses, others where you're looking at sort of the long-term adhesion of the sealant. But you've also done some durability testing with rapid cycling, correct?
Yeah, so you make a good point. There's really 2 ways to look at durability and the way something performs, right? You have all these different tests that are lab tests, and those labs create the perfect environment for products to be tested, quote unquote. So we have done that, and it's, there's rapid aging. It's called a 50-year wear test. So we've put our sealant through that type of testing, and what they do is we apply the sealant, they cycle to really, really hot, then they cycle it down to really, really cold and put some different pressures across that sealant and measure its durability and its effectiveness. So at the beginning of that process, our sealant was 99.9% effective, is what, as you would expect. After the simulated 50 years of wear, it ended up at 99.87% effective. So real little seal degradation. And again, full disclosure, that's a lab, right? That is not real world. That's not, that's not if you were to put it in a house that's being built in construction right now. So we were thankful for partners like Steve and Jake, and we've actually been working with Mandalay Homes out of Arizona for about 3 years now. And one of the first homes that we sealed for them, they have been kind enough to let us go back and continue to blower door that house. The one challenge we have is once you seal a house, homeowners don't typically like you to come back and visit them. They just want to be left alone. But we're lucky enough to have a couple houses in Arizona that we can test. In the first house that we did, we sealed the final blower door test was 0.6 ACH 50. And we went back, it was probably 6 months ago, a little bit longer, and it ended up at 0.7 ACH 50. So 18 to 24 months later, after AeroBarrier is applied, that's a pretty good result for that type of a house. And with a blower door that has that's a wind across the blower door as far as the change in that air leakage.
And speaking of research, you've been looking to expand the technology to be used in existing buildings, correct?
Yeah, we have. We feel like there's a really strong marketplace. There's so much existing inventory of houses that could be more efficient or could come up to the most recent energy code with a little bit of work. So we feel really strongly about the ability to apply our technology in the current inventory or in a retrofit environment. So we're working with the Department of Energy as part of the Building America project. Our partner is CEE, which is Center for Energy and the Environment out of Minnesota. And we're applying to existing structures. Now, typically this is at tenant turnover. So apartment tenant turnover or buying and selling of a property before someone moves in. We have done occupied spaces to date with this program, but it's really not something that we recommend at this time. But what we've been able to find is we can take these older structures that are significantly leaky or leakier than what they should be, and we can bring them up to the most recent code and make them more efficient, improve the mechanical system in them. And we're working through that with CE right now and through the DOE grant. The challenge that we have is when you build a house, you design a house for certain tightness, right? When you go into a retrofit house and you tighten it down, it may not have been designed for that. So when you think of building science and the implications of that, things change that you wouldn't expect them to change. Your bulk water management may change. Moisture moving through that house changes. VOCs are now trapped in that house when they may have been naturally ventilated, right? So you have to take those things into account and bring the proper mechanical ventilation or do the proper things in that house to make sure it remains healthy and safe. We have some installers that have bought houses and applied AeroBarrier before they moved in. And the most recent one, it was a 7 ACH house when they bought it. And he took it to 0.6 ACH 50 in a couple hours. He added an ERV and updated his mechanical system to balance ventilation. But it just shows that there is an opportunity there to take these older homes or the existing housing stock and make them much more efficient.
Yeah, I can't tell you how excited I am about this application. Because,
why don't you tell us? This is an opportunity.
Well, we don't have technology to address existing buildings, and I'm really concerned.
We do. It's called a bulldozer.
Yeah, either AeroBarrier or a bulldozer. I like that technological comparison, Steve. That's good. And it's actually, you're making a joke about it, but it's true. If, in Vermont, we just decided that we're going to spend more money on energy improvements existing buildings because Vermont is pretty much all existing buildings. There's very few new homes built in Vermont. But the problem is that if we improve the energy performance of the building, but we don't manage moisture better, we're going to move these homes into difficult situations rather than better ones. So if we have a technology that can comprehensively address air leakage, that way we're managing both energy and moisture better. That's the key, because I'm pretty concerned about how many of these homes are going to get.
Well, see, in Vermont, you get both, Peter. You get the rehab, and then you get the bulldozer.
Well, I was just going to say, that's what's going to happen. We're going to move more homes to Steve's current technology of bulldozing than we are to better air tightness. So, Steve knows this. My mantra is manage energy and moisture with equal intensity. AeroBarrier may be the way to do it with existing buildings, because the other approaches we have, those hidden air leaks, even in my own home that's about 4 ACH 50 after a deep energy room by room retrofit, I've got air leaks that are hidden. I can't get to them. I know where they are, but I can't get to them. So I want to be one of your first candidates for doing an existing home.
Paul, I have these images of Peter walking down the hall and like looking at the corner of the room and just grimacing like, I know you're in there.
Yeah.
Yeah, and I want to know if I can put on a type of mask and be inside when you do my house. Probably not a good idea, right?
Yeah, we usually don't let anybody inside. I mean, if someone goes inside, they are wearing a full face respirator, but we would prefer you stay outside and let the sealant do its
I
work.
thought you said it was just like bubble gum.
Well, the Aero Seal has the same material as what's put in bubble gum.
He's saying
AeroBarrier
that
is
if
more
I
like
wanted
a
to
caulk.
crawl inside my ducks while they did it, I could do that, but not my
There you
house.
Yeah.
So, Paul, we're going to push you a little bit here because you've got this technology, but everybody's always improving their technology. What's on the horizon for AeroBarrier?
Yeah, so we're actually really excited. We have been working over the last couple of years on what's next for the technology, and we've sealed thousands of houses. We've got tons of feedback, not only from our installers, but some of the builders that we're working with, and we've taken that feedback and we've developed what we lovingly call AeroBarrier Connect. This is the next generation of AeroBarrier. And if you attend that International Builder Show, you may have heard about it already, but it's a wireless solution to the current technology. So one of the challenges that we face today is the system takes temperature and humidity readings throughout the house as part of its way to manage the sealing process. And with only one point of reference, it can create issues with the house as far as how it's being applied. What we've done with the new setup is there's multiple temperature and humidity sensors in each of these sealing stations. So we've developed what's called a smart sealing station. And each sealing station has its own temperature and humidity sensor built into it. And that sealing station can now react independently of all the other sealing stations based on what that sealing station is experiencing in the house. So if a part of a house gets tighter faster than another, and sealant is not moving as fast as we would like it to, the system will actually turn itself off and not inject any more sealant in that air or in that room while the other stations continue to seal and inject sealant into the space. So we've developed these smart sealing stations that can work independently of each other, but they're all connected by a mesh network. And that mesh network then controls all the stations outside the house through our MCU and our laptop computer.
So you've got really high-tech installation systems. I imagine that only trained, sort of approved folks get to buy into the AeroBarrier system, correct?
Of course, yeah. One, if someone just picked up the system on the street, they may have a little trouble running it to begin with. But as part of our program, when someone buys into our company and our technology, we typically spend about a week out in the field with them. We'll go to wherever they're located and spend a week learning about the system, applying the technology on homes, and walking them through that to certify them to use the technology. So it's not really something you can just buy off the shelf at Home Depot and go apply. This is something where we're going to certify technicians to come and do the work before they can go and apply it in their marketplace.
And the sealant that you're using, I imagine you guys did a lot of research into exactly the properties you wanted for the sealant. And also, you're probably using a highly reputable, been around a long time sealant manufacturer.
Yeah, and if you're familiar with Tremco, who's known for exterior applied air barriers, liquid applied air barriers, Tremco is our sealant partner that we've used with AeroBarrier. So we've worked really hard on the sealant with Tremco to develop this proprietary sealant that we use. And one of the biggest changes that you'll notice about AeroBarrier is most sealants that you use in the build environment today are solvent based. Ours is water based, and that was intentional, right? If we're going to atomize sealant, we don't really want to atomize solvent. We want it to be healthier. We want it to be safe for occupants. So we actually made it a waterborne acrylic instead of a solvent-based one. So when we atomize it, we're using water and air as our method to atomize. So it's inherently healthier. It's inherently better for the environment. It's inherently better for the occupants that are going to live in that house. So we worked really hard on the sealant. It's Green Guard Gold certified, which frankly, it may not mean as much to the listeners here, but that certification is for hospitals and schools.
Yep.
Obviously, the occupants of those environments are a little bit more susceptible to chemical exposure. So the fact that it can be used in hospitals and schools, we feel good about it being used in homes. It's a National Green Belt certified product. It's an ultra low VOC product. And like I said, because it's inert and there's no chemical reaction, it's also very low to no off-gassing. If you're familiar with the Declare label, the sealant is also red list free. So again, we're really proud of the sealant. We worked hard to develop the sealant that we have, and we believe it meets all the needs of the marketplace today.
Yeah, I've been into buildings after they've been treated with your process, and I don't pick up any odor at all. Essentially, not even a whiff.
Yeah,
How
the
about
nice
you
thing,
and your
because there's
nose
no
and Jake's
chemical
home,
reaction. Sorry, go ahead, Peter.
I was going to say, what do you think in the homes Jake did? Yeah. You got your mic on mute there, buddy.
We were back.
Yeah. So when you did Jake's home, no odor?
No odor, none whatsoever. But I had a question for Paul. Talk to me about scale. What's the largest building you guys have done, or largest single AeroBarrier install or procedure?
Yeah, so it's funny. We just talked about the AeroBarrier Connect, which is our new air sealing system. That comes with a new fan. It's a centrifugal fan. It's a high power fan. It gives us much more headroom than the current fan offers us. And we just sealed a 225,000 cubic foot structure with one fan.
With one fan?
Yeah, with one fan, with one system. That was
Hold on. Put your seatbelts on there,
being efficient. Steve, you're familiar with high performance barns.
Right.
We did a barn that was 225,000 cubic feet with the new Connect system.
So is the new fan the same size as a typical blower door? It's got to be bigger?
It is bigger.
Yeah.
So it's a centrifugal fan, and instead of having to put it at the door or the entryway of the house that we're sealing, it has enough power that we can actually leave it in our trailer in the parking lot and run lay flat to the front door and pressurize the space without moving the fan from the trailer.
Interesting. And then you just have to have a new, pressure to volume, relationship, or pressure to airflow relationship for that fan.
Yeah, you update the coefficients and the formula.
Yep.
And we have a flow station at our headquarters that we've been working through. And obviously we've tested in the field. So we've been in beta trials for over 8 months with the AeroBarrier Connect system and kind of honing that, dialing everything in. And that fan and that system provides the exact same results as a standard blower door would.
What about multifamily, Paul? Have you guys done that?
Yeah, so it works really well because you can leave the fan at the end of the corridor and just run lay flat to each individual door not move equipment. So again, we believe the new system will gain so much, or add so much efficiency and allow our installers to do more work in a day. So we're really excited about what that new technology is offering the marketplace.
And since, sound and noise can travel by air leakage pathways, you must get noticeable improvement in terms of sound performance with AeroBarrier as well, right?
Yeah, so we've done some testing, and as you can imagine, sound testing in a construction environment is a challenge. But we have done testing, and if you think of the human voice and how sound travels, the higher pitch tones, air sealing in general, again, this is not specific to AeroBarrier per se, but air sealing in general can reduce those higher pitch tones up to 80%. right? Because they're just traveling through the air. There's not much vibration. When you get to the deeper tones, the bass tones that actually vibrate as they move through the air, there's less of an impact. It doesn't stop the vibration. You're still going to, it's like the car driving down the street where you can hear the bass in the trunk. You aren't going to stop that completely from air sealing. It does have an impact. But we stop a lot of the higher pitched, human voice tones up to 80%.
Yeah, so I guess that means that for the lower tones, the mass approach, like you add like a heavy, dense gypcrete, to catch the lower frequencies, as opposed to the higher frequencies can, be more managed with air tightness.
So you can improve your STC rating just by how you talk, Peter.
If I talk low, we gotta go.
Exactly.
Hey, speaking of
What if you talk very high?
Hey, Paul, this is so exciting. It's, a truly building science-based technology, just really going to change the market. And I really can't wait to get to one of your projects with the new Connect system. That sounds awesome.
Yeah, we're really excited about it. And one thing I would say, any builder that's interested in AeroBarrier, right, give us a call. We'd love to work with you. And just, it's not just about applying AeroBarrier because you want to hit a code or an air tightness target. Let us work with you, and we'll figure out the right stage of construction and when the best time to apply is and how it works with your current build structure or build process. We don't have to be an add-on. If you work with us and we can get a consistent tightness, there's other trade-offs like smaller mechanical systems or right-sized mechanical systems. Maybe there's other hand sealing things you don't have to do, but we can work with you and partner with you in that sense. And we can do energy modeling for you. We can work with you to understand what products should and shouldn't be used. So if you have an interest in AeroBarrier or just want to give it a try, give us a call and let's see what we can do. And we're happy to work with you to figure out how AeroBarrier would fit into your construction process.
So, AeroBarrier technology with Paul Springer. Can't thank you enough for coming on to the UnBuild It podcast. Steve, great to see you today and work with you again.
Always a pleasure, gentlemen.
So
as always, I appreciate you both.
Let's call it a wrap, and we look forward to learning more about AeroBarrier's new Connect system.